It's setting up. Yes, we are there. I'm putting the link in the chat.
Hmm.
Okay,
All
can
right.
we get started? I'm hearing myself again.
I have not put it to the speaker. I'm on the
Okay,
head.
let
Hmm.
me switch it off. Okay. So before we start, thank you, Bishwa. Thank you for joining this study hours. So the objective of this call is to understand these program metrics. So to deep dive into each of these metrics. So as program managers, project managers, we will be asked occasionally to share different metrics in different reports. And in this call, we want to target it at three
Hmm.
levels. At the team level, what are the best kind of metrics which we can show? It can be with respect to the product or with respect to the process or also even the progress, different kind of metrics. And same we will do at for team level, maybe we'll take 5 to 10 top, like what the main things which you use, what I use. We'll try to populate it in a kind of a tabular format, and then we'll go to the program level. So the program level, what are the different kind of metrics? We'll do that. And also parallelly, we'll also see from the engineering or technical or software standpoint, what are the key metrics which will be of relevance for us. Okay, so
Yeah.
are we good? So with that, let's get started.
Hmm.
And we'll do this as a kind of a collaborative session where I'll share you the screen, share you the doc. It's a collaborative doc. So you can add items, I can add, and we can go to the internet, search and find the information we need, and we'll populate it.
Sure. Sure.
Okay, so let me share my screen with that context. I have shared the access to you. So can you check once if you're able to edit?
It did. Uh, 1 second. I have to fix the document. We are. I think we are actually the same document, right? I have this document
Yeah.
open from the
Okay.
Zoom. Yeah. You're right. I think we can go ahead.
You're able to update, right? Okay, cool.
Yeah.
So we'll start with the team level metrics.
Hmm.
Any first thing which comes to your mind?
Exactly. This is the sprint velocity.
Velocity, right? Yeah.
Yeah. Burn down chart and
Yeah, burn down chart.
yeah, burn down chart is what we use very common. And
Sprint variance.
sprint report. There is another. Yeah, there's something called a sprint report. I think that is part of the Jira. So I think there you can find that option where it shows that how many tickets are being added and how many tickets are being completed and it is still incomplete and removed from the sprint or
Mm.
newly added to the sprint. All those things are being mentioned there.
Sprint reports in Jira, right? Yeah, there are a lot of
Yeah,
metrics
yeah,
there,
yeah. There are a lot of metrics,
add-ons.
but currently we are more focused on this because it's helped to see the overall picture of the sprint.
Correct.
Because sprint report also shows the burn down chart also. It shows the
Correct.
burn down chart along with the tickets.
A burn down chart view along with other key metrics. Okay. So we'll
Hmm.
deep dive into each of these. Velocity, burn
Sure.
down chart, sprint variance, anything else which
Uh,
comes to your mind? Mm, Velocity, predictability.
I think there are many, but I think this
Defect
one.
rate, defects,
Yeah, I think they are there, but
like in each sprint. if
Mhm.
there is something which is being reported from production,
Yes, production defects
slippage,
are there.
yeah,
Yeah, yeah, there are production defects,
defect
but
rate.
those are something because production defects for us is something which happens in a mid sprint. So we always have reserve tickets for the such emergency, so that it
Hmm,
doesn't impact the sprint velocity. Because if you have there are a lot of spillover, we try to control the spillover.
great. So the approach you're following is at the start of the sprint only, you are expecting some kind of work
Yes, yes,
which would
we
come,
have
and for
always
that you're
reserve.
reserving that capacity. That is great.
Yeah, yeah. 10% of the sprint velocity is our reserve for the production support.
Correct. So, what else? One, two, three, four. Shall I check in the internet once? Let's see. Hope you're able to see
Yeah,
my entire screen, right?
yeah. I can see. I'm also checking my end here. I'm just trying to log in.
Yeah. Team level.
But I think the one there are many metrics. I think, but the one which is useful for us, I think these are a few
Yeah.
metrics that we find it to be useful.
Velocity,
Yeah.
burden chart, sprint variance, defect rate.
But maybe you can explain about the sprint variance because I'm not familiar with that.
I'll do that. Yeah.
Hmm.
Defects and cycle time and lead time. Did you calculate any time? Cycle time.
No, not in our case.
Okay. So we also don't commonly do that, but in
Hmm.
few type of teams, especially if it is a
Yes.
Kanban team or those kind of things, at the
Yeah.
team level, we will try to put this. So we'll put this. So one, two, three, six. So these would be the
Yeah,
six.
lead time and cycle time.
Yeah,
Yeah. So because actually we can see the turnover of the defects.
correct.
I mean the tickets.
Yeah. Okay. So first, we'll start with velocity. So velocity is a progress metric, right? It's a progress
Yeah, it's a
metric.
progress metrics. It's a kind of a committed and completed metrics.
Hmm. So why this metric matters? What gesture or insight it supports? Interesting. Hmm.
These metrics are okay.
Why it
In my
matters?
case,
Hmm.
in my case, we have a cutoff ratio of 85%. Anything below 85%, we have to give a justification why it is having it below 85%.
Hmm.
If it is as long as above 85%, we are good.
Okay.
Anything, yeah, we have to have explanation call for below 85%.
Okay. So helpful. Can I say like this? Helpful to
Mm.
uh, plan and predict the upcoming team, the upcoming work for the team, and uh, to plan helpful to plan and predict the upcoming work for the team. Um, because with velocity over a period of time, when it
Mm.
stabilizes, we'll be in a good position to estimate the futuristic trend of this team, whether it is for releases
Yes.
or for the
So what
sprint.
happened in our case is velocity. Ha- we try to have a average value for it. So we know that what is our average velocity. In that way, we
Correct.
can predict that how much work we can take up
Yes,
based on the available
exactly.
capacity of the team. Yeah.
Yes. So in my previous projects, what we did is we took an average velocity of the last six sprints.
Ah, yeah. There is option for selecting 3 sprints or 3 months
Yeah.
or 6 months. Yeah. Right.
So typically, velocity, how to calculate is average velocity of the last three or six sprints.
Um. Uh. Is it months or sprints?
Sprints. So in in
Uh,
uh, so in case if for the last three sprints, if the team delivered 20, 25, and 20, then we'll average it out and then take that number as the velocity for this
yeah.
sprint.
Yeah.
It can be six
Again,
or
depends.
sometimes it can be three. Typically three to six. Yeah, you were saying something.
Yeah, uh, I think the one which we have is basically having months.
Months,
Three
is it?
months, like, yeah, in 3 or 6 months. Let me just correct it. I'm just checking that. But
Okay.
I'm quite sure that is months actually.
Hmm. So here, after this type, I'll add one more column, definition, so that we are all clear. Let me check a standard definition from,
Yes. Okay, JP, this it's
yeah,
months. It's 3 months or 6 months, 12 months, and custom also is there. Custom may be the one which we can decide on the time frame, that what time frame we are looking, we wanted to look into.
velocity. Okay.
Hmm. Because sprint in our case is 2 weeks. There
Hmm.
are maybe people who has 3 weeks also sometimes.
Okay, so I'll take this. You can see my screen, right?
Yeah.
Where I'm opening Google. Okay, so the definition, standard definition is this. It measures the amount of work a team completes during a single sprint. Typically, I mean, velocity
Mhm.
typically is this, but when you say average velocity, that differs from org to org or company to company. What is the standard? And what you're saying is that average of the last 3 months. So for each month, you have some velocity number, is it? I think I lost you. Yeah, the screen is frozen for some time. No worries, let's wait. Okay, he should be back in some time. Meantime, let us continue. Okay, product. Oh, no, velocity. What is it? Average velocity of last 3 to 6 sprints. Frequency. Each sprint calculated each sprint towards the end after completion, after sprint completion. Okay, so velocity is good. And then burn down chart, progress, process, product. This is also a progress type. What is the definition of burn down chart? Burn down chart. Okay, so a burn down chart typically plots the work. The work on a project or sprint against time. So time you take in y-axis.
Okay.
You're back.
Yeah, back online.
Cool. Okay. So here I tried to complete what is velocity, type, progress. Definition is it measures the
You
amount
able
of
to hear
work.
me?
Yeah, yeah. Me? Am I audible? I'm able to hear you.
I can't hear you. One second.
You're clear.
Mm.
Able to hear?
I need to join back.
Not yet, is it? Okay. While Vishwama joins, the burn down chart progress, plots the work on a project, work on x-axis. Sorry, work on y-axis, and then
Yeah, now I can hear.
yeah, you can hear me, right? Cool.
Yeah.
Yeah. So while you're away, I
Mm.
try to do it for velocity. Where
Okay.
it's a measure of progress, measures the amount of work a team completes
Burn
during a
down chart.
single sprint. Helpful to plan and predict the upcoming work for the team. Average velocity of the last or six sprints or any duration. It depends on the organization. Sometimes it may be a week or a month also, in case in your case how you're doing. An average of that. And then it's calculated after each sprint towards the sprint completion, after the sprint completion. Am I audible?
I have to. Mm, 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 mm.
Okay. And then okay, let's move on to the next one. Burn down chart and then sprint variance. Sprint variance also is a measure of progress. Sprint variance. Difference. Able to hear me now? Am I audible? Am I audible?
Yeah,
Yeah.
I because this Bluetooth things doesn't work.
Yeah, now it's clear. Loud and
Yeah.
clear.
Okay.
Okay. So while you're away, I
Mm.
was trying to fill in that there is the table. So finish for velocity. Um, so here, this how to calculate the average velocity. It sometimes depends. Sometimes teams take 3 months or like one
Mm,
month or duration, or sometimes they go with sprints also, 3 sprints or 6 sprints or
yes,
whatever.
yes,
Basically, the
yes.
average.
It's all tailor-made for the.
Yeah.
Mm,
And then calculated towards calculated for each sprint after the sprint completion.
mm.
Since once we are completed only, we will
Yes.
get to know what is the Total number of story points. Okay. So
Yeah.
velocity we are done. Next I moved to burn down chart. And here
Mm.
I mentioned the definition as it plots the work which is on y-axis of a project or a sprint against time. So time will be
Mhm.
on x-axis. A kind of a simple
X.
definition of a burn down chart.
Yeah. X and Y, right? Okay. Yeah. Exactly. X is the time. Yeah.
X is the time, and basically
Yeah.
we plot the
Y is
work.
the work.
Y is
Mm.
the work. Y.
Purpose. Okay. This is also to track the progress of the team.
Yeah. So how it will help? I mean, so specifically what
Okay. It's like we have plot the time and the work, and it draw a
trend?
yeah guideline. Based on that, we have to stay close to that. If as long as we are going above, far away from the guideline,
Hmm.
it shows that we are not picking up with the plan. We are deviating with the from the this one. So we try to stay close to the
Yeah.
guideline.
It gives a baseline progress. How do I articulate it? It gives
Guide. There's a line that shows guide. Yeah,
it gives a
progress guideline,
progress baseline.
baseline. Yeah,
Progress baseline.
exactly,
Ideal progress baseline.
exactly. Ideal. Yeah,
Yeah.
the happy path.
Yeah.
Yeah.
It gives an ideal progress baseline.
Mm.
Um, and shows the actual progress against it. For now, we'll
Uh,
keep it like this. I want to change anything.
okay. Gives the baseline and shows. Uh,
So
okay,
this is one
I
point. Yeah, you can also
I need
add
to follow because sorry, the baseline.
anything else. Other point what I put it is good to visualize a trend over time.
Right, right.
So this is one point.
Um, and it also you can actually forecast that are we going to complete the target
Hmm.
of the sprint goal within the time frame.
Forecasting
Yeah,
can
forecasting.
be
The
done better or effectively.
Yeah, can be done effectively or within the time frame, within
Hmm.
the sprint. Yeah.
Forecast. I'll put some more terminology here. Forecasting
Uh,
can be done on the. So basically, what I'm trying to say is on the success we can predict
yes.
whether.
We can
Yeah.
understand by looking at the graphs that
Whether
are we
yeah.
going to meet the
Correct. Yeah.
yeah the
Over
sprint goal
time
or
we
not.
will be able to meet or not.
Yeah, meet the sprint goal.
Hmm.
Forecasting can be done to predict whether we can meet the sprint goal. I think that
Forecasting can be done to predict
yeah, it's a
if
prediction.
we
It's
can
nothing like
meet the goal on
time.
as planned or on time.
Yeah, on time.
On time. Hmm?
Yeah,
Okay.
right.
Okay. These three things. Why we use a burn up chart
Mm. Burn down.
or a burn down or a burn up. Yeah. So sometimes burn up we
Yeah,
use for releases.
yeah. It's also
Burn
similar,
up or burn down. Yeah.
but their characteristics a bit different
Correct.
from yeah.
If you shall we write that both? It will
Yeah,
be
let's
easy
complete.
to
Let's
write.
complete this one.
Yeah. Let's complete this basic
Yeah,
one version. We'll go and then we'll go to the details.
yeah.
Okay. How to calculate? How to calculate or how to plot?
Um, I think it's simple. That number of story points for that sprint divided by the available working days. So in a 2 week sprint, we have 10 working days, and let's say that we have picked up some story points of 200. 200 story points, then it is expected that every day we have to burn 20 story points to meet the
Hmm.
target.
Hmm.
Mm.
Hmm. You want to update this?
No, no, it's okay. You can continue.
Okay. So,
That's fine.
uh, calculate total amount of work to be done,
Mm.
amount of work, which is story points
Yeah,
done, and then divide it,
yeah,
by number of days
right.
to get uh,
Um,
per day how much we have to burn to
yeah,
get
that average
average.
speed to be burned. Yeah,
Yeah, get average. mm,
speed to be burned.
yeah, to be okay. And
Mm.
then once we get that, plot a table,
Right.
with on the y-axis we need to have
The story points.
with y-axis for story points and
Mm.
x-axis for
Yeah,
days.
time. Yeah,
Okay, and then basically use Excel for this.
yeah. You can do Excel, and even if they're using Jira, I think
Yeah, yeah,
they are already defined.
correct. Use
Yeah,
tools like Jira or
right. It's very
spreadsheet.
user friendly, easy to use. It shows the lot of graphics to understand.
Correct. Okay, so this we are
Mm.
clear.
Mm.
Okay, frequency. Once in a sprint, right?
Yeah, once in a sprint.
Or daily you have to update, no?
No, yeah. I mean to say that depending on the amount of that
Hmm.
user story burn, we can start plotting the graph.
Hmm.
Uh, but the entire graph is for one
Yeah,
sprint.
I
Yeah,
will say typically each sprint
yeah, yeah. Each
and
sprint.
can be plotted ad hoc based on request also. If someone asks,
Yeah,
you can
yeah.
immediately use.
So we normally we get to know every day like how much of story has
Correct.
burned. So based on that, we can plot.
So okay, so each sprint the chart will be prepared, which can be uh, published as needed, whenever needed,
Hmm,
right? So it is always there, but once in a sprint, we have to make all those changes.
right.
Okay, so this is also done. Sprint variance. This one you are asking, right? So
Yeah,
sprint
this I'm
variance.
not aware of this actually.
Uh, so this is nothing but the measure of difference between
Hmm.
what we have planned, like what we have committed at the start of the sprint and what we have completed towards the end of the sprint.
Okay, 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 okay.
Basically, the
The
commit
the
versus complete
deviation of kind of
deviation.
thing.
Yeah.
Okay.
And you already mentioned that in your teams,
Hmm.
it should not go below 80% or something.
Yeah,
That, that
85%.
is
Yeah.
that is their that is sprint variance. So that's the
Okay.
control we have around sprint variance, where we want the teams to be within that region only.
Yeah, understood, understood. Got it.
So it is
Okay.
more predictable.
Mm-hmm.
So why? So whatever I said now for teams, more predictable
Okay.
mm, in their delivery
Mm-hmm.
and to plan releases effectively. Basically,
So
once if we
isn't it similar to what we have about the sprint velocity? Is can be that be
yes, so velocity is a basic thing.
hmm,
On top of that, we need sprint variance also because this will normalize a lot of things. When I say that, what I mean is,
hmm,
in case if our variance is within a certain bound only, we will have much more confidence that this team will be able to do. Sometimes what happens is sometimes the team will deliver like 10 story points in one sprint and
Mm.
maybe 20 in another. Again in
Okay.
20 in another, again in 5. But
Mm.
overall average, we may get some number.
Right.
But unless there is some consistency in their outputs, it will be
Mm, mm,
difficult.
mm,
So this
mm.
this builds on top of velocity
Okay.
in the context of releases, planning for the releases, those
I
things.
mean, in the larger perspective.
Upcoming in the larger perspective, yes.
Okay.
Okay, and how do we calculate? Basically, this is the mm, committed
Mm.
story points
Committed
mi-
and completed.
minus completed.
Okay.
Yeah, basically
Okay.
the planned minus this one. What is the difference?
Okay. The difference, or is it? It's in the percentage.
Percentage.
Okay.
It's in a percentage.
That is like completed divided by committed. That will give you the percentage.
Completed divided by, yeah, that will give the directly the percentage, right? Yes.
Yeah. Uh,
It should give, right?
yeah, it normally does, but maybe you have to multiply again with 100. That will give you the round of number, actually, I think. So,
Let's check once.
example, we have completed 175 out of 200 story points. That gives you 87.5%. So, you multiply by 100, it will give you that round of figure. You can try that. Maybe you can bring
Okay.
up in the shared
Uh,
screen, and then that will be
so
useful.
see, so I've just checked the one other source where I
Mhm.
came across this. Just check this once.
Okay. Estimated
No, this
hours.
is completed. Sprint variance is equal to completed hours. Completed.
Maybe I think this has been calculated using the hours spent.
Yeah. Check this. Committed story point minus.
Oh, maybe
Oh,
this
this is
is
like
new.
complicated, right? Not this
Yeah,
one.
no, no, not complete. But I
This
think I think this might be the right one actually. I was thinking that. Let me also search here.
Yeah, yeah.
Sprint variant.
Yeah, the definition we got it, but the calculation, the
Yeah,
percentage.
yeah. Sprint variant. Okay, just try to come up with that. Comparing actual and planned velocity. Formula. Okay. Uh, okay. This is more of a actual velocity minus average velocity divided by average velocity. Uh, Let me see if I can ping you that.
Hmm. Into 100, is it?
Yes, into 100.
Okay. Can you put it in chat? It will be. I'll
Yeah, I'll
check out.
start. Very.
I did this calculation, I mean, on the tool many times, but internal calculation, right? It is good to know.
Yeah, yeah, it's good to know.
Hmm.
Explanations. Okay, I'm putting it in the chat. Oh, team chat. Uh,
Yeah. Okay. So I'll just directly put it here.
hmm.
Cool. Frequency once in a sprint, right?
But but
Ah,
this is interesting thing. Let's say, for example, the example is that if your average velocity over 5 sprints is say 45 story points,
okay.
and in the current sprint The team deliver 40 story points.
Okay.
Then what is a deviation? What is a variation? Variation. Yeah. So can you try this one? I'll say committed is
Okay.
equal to uh no. Sorry, not committed. It's a average of
Average.
last
So
five.
average is last five is 40.
45.
Okay, last five 40. Okay, let me do it
Yeah.
different.
I'll just read out.
Yeah, yeah.
Average velocity over five sprints is 45 points or the story points.
Huh.
And in current sprint, it delivered 40 points. Are you typing?
Yeah, you're able to see my Excel?
Excel I'm not seen. I
No,
can't see
no, is it?
Excel. Yeah, I can see that in document.
Okay, opening. No, here I can't open clearly. Let me open a calculator.
Okay. I'm just pasting it the one of the calculation here. Yeah, can you see that?
Okay. If your team planned 40 story point but completed 35, then sprint variance is equal to correct, right? Shall I put it directly there?
So what my actually JP, the thing was velocity, sprint velocity was calculating the committed divided by completed. Complete, yeah. But here variance is like the deviation, how much deviation it happened.
Correct. Variation is the deviation. Yes.
Yeah. So it is showing that there are 12.5% variation.
Correct.
Yeah. So yeah, this is the one metrics I think will help us to that to understand why the team has been deviated from the average
Standard.
value.
Yes.
Yeah. Right.
Yes. And this we typically try to have it within 20% of deviation.
Yeah.
Plus
Something.
and minus.
Yeah.
Yeah. So some organizational standards. So for us, we are following 20.
Yeah. In my case is 15. Say like 85%
15.
is the cutoff. Yeah. So not should not be go beyond the 15%
15%.
spin
Okay.
variation.
Okay. So this
I can even try
calculation of
out this applying in my
yeah,
day-to-day work.
yeah.
Yeah.
Okay. So I put
Uh,
the example also here.
uh,
Cool. And frequency once in a sprint, right?
yeah, I think this should be once in a sprint.
Okay. Any trend, industry trend. So in your case, you're saying 15. In our case, it is 20. Let me check internet. What is the typical teams following?
Okay. At least
So here I got few links which says not more than 20. The lesser the
okay.
better.
Yeah, I think yeah, lesser the better. It's lesser the better. That even in the uh your sprint details that we capture,
Mm-hmm.
it is that LS lesser the better.
Mm-hmm. So
Uh,
I'll put 20% and the lesser the
LTB.
better.
Yeah, LTB. They call it LTB, lesser the better.
Oh,
Yeah, there is a term that used actually. Yeah, there is
oh,
also more the better is also there. More the
okay.
better. Yeah. Maybe in a velocity case, it is like sprint velocity case, it should be more the better. And in
Uh,
this case, it's a lesser the better. I think this is a good to know.
okay.
LTV and more the better. MTV.
Cool. So
Yeah.
we completed three.
Mhm.
Let's go to defect rate. Defect rate, whether it is a measure of product progress or a process. Defect rate, product.
Yeah, I think the quality. Maybe here we may have to discuss about the defect density also.
Hmm, defect rate and also defect density also. Yeah. So I will put for product metric.
Uh,
Defect rate.
do we have something called as a quality also? Quality metrics?
Yeah, quality metrics also we have. So that
Hmm.
has segregated separately into this engineering metrics. So
Okay.
here we'll put all those, the code
Okay.
coverage, test metrics,
Uh-huh.
all
Engineering
those.
part.
Yeah. Okay. So this defect rate, uh, how many defects found in production? How many defects slipped to production
Yeah.
over last one sprint? Hmm?
Right. Yeah. Defect. Also, there is also a formula to calculate that actually.
This is the definition what I have found. A measure of how many defects are found in production software.
There is a measure how many defects are found in production software related to the work amount of the work completed. Okay. It could be also during the sprint also. That's okay.
During the sprint also. So for us, we will take
Mm.
during the sprint.
Mm.
We'll took the amount of work completed in a sprint. Hmm?
Yeah.
Why? It gives the quality of the product.
Yeah. It's in quality of product.
There are many reasons. Jot it down.
Yeah.
It gives the quality of the product. Gaps in testing.
Yeah. The slippage happens because of that also is one reason.
Then
Or maybe wrong implementation also.
so wrong implementation. Testing should catch, right?
Yeah, but if the story points, if the user story is not been understood correctly, or
Hmm.
the task is not been understood correctly, then also it's like because I think if you look at that way, it can drill down to the level where you define how you define the story point,
Story.
user stories also,
Mhm.
right?
So, gap in testing and um, re requirement miss, is it? How do I say it?
Da, 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 da.
Not capturing all the requirements, right? That should come out.
Yeah, that can be many, I think. But considering the fact that the PO has done his work,
Mm.
the developers has understood the story, the user stories, and then it happens that could be the one gap in testing or
Mm.
the code coverage.
So, mm, can be gaps in requirements
Yeah,
as well. I'll just put it like this. It will
yeah.
see.
It can, yeah, it's possible to have this
Many,
kind of
many, yeah.
slippage. Yeah.
Requirements. What else? Um, why defect rate is important?
Oh, why it is important? Okay. I think it shows that the quality, it defines the quality of the product. And then,
Even the customer users also will be upset, right? I'm just
yeah,
thinking,
the
how do we put that?
stakeholders, yeah, the stakeholders, the customers will not be happy if you have a lot of
Yeah,
bugs being slipped.
unhappy users.
Yeah,
Hmm?
maybe users.
Okay. How do we calculate defect rate? You're saying there is some formula, right?
Yeah, there are few different formulas are there. Okay, I'll just paste it, the
Huh.
formulas. Oh, sorry, what is this? Okay, correct, correct.
Option A, based on total work delivered, based on total defects found. Oh, okay. This is big formula, right?
No, it's not that big. I think something is wrong. I just tried to take a screenshot. I think it's a
Okay.
simple screenshot. To your, why it is not allowing me?
Maybe just like a kind of simple, like which we
Can you
can use
copy
general.
and put it in a notepad and then maybe
You
uh,
can directly put here also in this
no, I
table.
mean to say that number of okay. I'm just trying to share it, but I don't know how we can make it because I'm not able to get the screenshot. Why?
Okay. Which any website or anything specific, anything you checked?
Yeah. 1 second. I will just see if I can put it. Yeah, give me a minute. I'll
Okay.
just put it in the notepad and then maybe option A percentage wired number of defects sprint. Why I am not able to get the screenshot? Snip tool. Yeah.
There are some variations to this defect rate also, which is, as you said, defect leakage or defect density.
Mm.
I'll also capture it here somewhere.
Yeah,
Defect
I'm
rate.
just pasting an image.
Okay. Defect rate variations, defect density, and defect leakage rate. Okay, you put, I downloaded it. I'm not able to see that. Or can you read it out? I'll write it as you speak.
Okay. So actually, the defect rate, the the rate is in percentage.
Okay.
So there is a number of defects found in the sprint.
So a defect rate percentage is
Mm.
equal to
Equal
number of
to
defects
defects found in the sprint, in the current sprint,
in sprint
divided by
divided by.
number of user stories, total number of user stories.
Oh, okay. This is a slight different variation, right?
Hmm.
So this is about a defect rate within the sprint.
Yeah, there are two. There are two are there.
Two,
Other one
yeah.
is after the defects found in the production. There
In
are
the
two
what
things.
is that? So I will write
Defect
both.
found after after sprint. The second
What is the
formula is after sprint.
okay?
Okay, divided by
Number of defects found
after
uh,
this after sprint.
after the sprint.
Sorry, this is the leakage part.
Leakage, yeah.
The one which is leaked to the production.
Correct.
So defect found after the sprint divided by
Divided by.
the total defects that is
Oh,
found during the sprint and after the sprint.
okay. So this is a different concept then, right?
Yeah, this is a different concept.
Interesting.
And we
Okay.
have to multiply by 100 to get the round of number.
Okay. So
Uh, is it possible that I can type?
yeah.
I can see it here. Okay. Uh, this is the one, right? Okay, defect percentage rate equal to
Is it working?
number of defects found during the sprint, okay, divided by total as to total user stories or the total user story points, total SP delivered, and whole thing multiply by 100
Okay.
into 100. Yeah,
So I'm not
this will
able.
this will give the defect rate.
Okay. Mm, Okay, where did you add that?
Okay, I just add. I mean, I just follow that what called it. I just sent a to follow. You're not following. You can click on that
Okay,
follow button.
yeah,
Yeah.
yeah.
Okay.
Yeah, I'm back.
Yeah.
Okay, so where are we? It's a good discussion, huh?
Yeah. Yeah. Definitely, I learned quite things. Seriously, it's not
Yeah,
because
and
we
see,
never comes in our mind because we
correct,
all
correct.
focus on the what we are seeing on my project, right? It's not beyond that. So
Correct,
here
correct.
we are seeing combined
Yeah,
studies help.
and that sprint variance, so many
Mm.
times we are tracking since long, but the calculation part right now I actually saw because the tool gives everything for us.
Yeah. Yeah.
Okay, so you can see my screen, right?
Yeah. Yeah. Can see now.
Okay, defect rate. Okay, this is what you added.
Yeah. Defect rate I added there.
Okay, number of defects found during the sprint by total story points delivered. This is what I'm seeing.
Mm.
Okay, and then we wanted the other version of it also, no?
There is a the second one was the leakage rate.
Leakage.
Defect leakage. I think that will complete here. We'll do it
Okay,
here or
yeah, yeah. We'll
okay.
keep it for separate. Here I put,
Mm.
then we'll do it
Yeah,
later.
I saw that you added here. That's why.
Okay, okay.
Mm.
And here I'll put mentioned within the sprint so that it will be clear.
Yeah. Then every sprint, I think, will have different defect rate.
Correct.
Yeah.
One is internal to the team, how we are performing, and other one is this leakage, how
Yeah.
it is with respect to the users.
Yeah.
Okay, frequency once in a sprint, right?
Yeah. Just single one sprint.
Once in a sprint. Desired trend or target defect rate, how much less it should be.
Uh, I think this is something that we need to have the lesser the better option, I think.
Yeah, defect rate. Any industry metric, average, benchmark,
I'm not aware of this actually.
defect rate.
Yeah, benchmark they're talking about is 0 to 5 is good, 5
Okay,
to 10 is acceptable, above 10 is need improvement.
okay. So we'll put that.
Yeah,
0 to 5% acceptable.
0 to 5 good,
Oh,
good.
good is it?
Yeah,
Okay.
good. I mean, uh, if you segregate the percentage wise,
Hmm.
0 to 5, anything within the 0 to 5 is considered to be
Good.
okay.
Okay.
Okay, not yeah. Good would be the wrong word.
Yeah. Acceptable.
Acceptable. No, acceptable is 5 to 10%. 0 to 5 would be like, say, um, the metric should not be red, actually.
Hmm.
Till 10, I think the matrix is not going to be red. But I don't know, it's too much, I think. And 10% is also very high, I suppose.
10% high, correct, right?
Yeah.
Should not be acceptable.
Yeah. It should try to be zero.
So then
Maybe
we'll
the
put
metrics
0 to
have,
5 acceptable. Okay.
yeah,
And then 5 to 10 needs improvement. Is it?
exactly. Yeah, let's keep like that.
Hmm.
And post sprint, ideally should be below 10%.
Hmm. Yeah, post print it should be much lesser because it is going to users, right?
Yeah.
It should be 0 to 1% or something, 0 to 2% only.
Maybe, yeah. We can have, I think, again, this all depend on how we define,
Correct.
yeah.
Correct.
There is no um, one formula works all, right? It's
Yes.
kind of a,
Hmm. And depending on the standards or
yeah,
benchmarks they want to target, their standards they want to achieve.
everything is tailor made. So I
Yeah.
think it's a more of an organic way of how we can bring in our idea to improve the quality. So initially, I think in the beginning we may accept 10% also as acceptable, but as we get matured, I think we expect that it to be reduced as we go on.
Hmm. Yeah. Cool. Let's move on to the next one. Next to
Cycle
these two
time.
are more of Kanban metrics, cycle time.
Yeah.
And here, I think this is a metric of process.
Yeah, it's a process, I think. Should be a
Correct, no?
process. A
Yeah.
progress, huh? Progress or process?
Pro
Progress. It's a
it,
progress, I think. It says cycle times measure how long it takes for a work to move from in progress to done state.
so
In
there
progress.
it is giving the efficiency of the process
Yeah,
so that the work will move from one state to other,
yeah.
not
So
the actual work.
picking up from to-do list to in
Yes.
progress is
Yeah.
it's a no brainer. It's a child
Yeah.
game. But from in progress, once you pick up the work and putting it to the done state,
Done
I
state.
think that is the cycle time that we require to calculate. And it also defines that whether we have estimated the story points correctly or not.
Hmm.
The complexity of the work.
Hmm. Yeah.
If the work is complex and then we are putting it wrong story points, that is also one case that we can catch there.
Yeah. Yeah. So a lot of things will come out why this
Yeah,
cycle time is more or like how it is varying.
right,
So type will put for process. So it will give the process. I mean, how are we doing it?
right.
Measure of that.
Mm.
So it's a process metric. Definition of
Uh,
cycle time and lead time.
cycle time is the time taken for a uh,
Work item.
for a work item to move from in progress to done state?
In progress or start?
Yeah, in progress means the time when you move that into the
Okay.
column, that in progress column,
Okay. From start of in progress,
to the
start
done
of
state.
in progress to
Done.
done state.
In some cases, we also have review in between, because in our
Correct.
case we have review. So we have in progress and review and then done.
Correct.
So sometimes this, I think, cycle time can also play a role of delaying the thing from moving from in progress to done if you have review, because normally our architect, he does the review of the things, that peer review kind of thing. If he's busy, then he piled up in his sprint board, and
Cycle
he
time will
doesn't.
increase.
Yeah, excuse me, I
Yeah,
have
yeah,
a call.
yeah, yeah.
Yeah, hello. हाँ भैया. हाँ.
So lead time. Let me meantime populate what I can. Cycle time and lead time.
Yeah, sorry.
No worries.
Amazon delivery.
Okay. Okay.
Okay.
So cycle time.
Yeah.
Time taken. And what you're saying is that in between reviews and other things would come in between the done and start, which
Mm.
would increase the cycle time.
Yeah, there is chances of increasing the cycle time, because what in my case I observed is that if the peer review is been sent for the peer review, and the person who's going to review is having other work, and it has been piled up in his story in his board, that could actually impact the cycle time.
Yes, definitely.
Yeah. So this is one
Basically,
case
these
that
are the
I.
yeah, yeah.
But
Basically, these are the wait times.
yeah, these are the wait time.
Yeah.
Yeah, not the cycle time, but actually it's a wait time. So there
Correct.
comes the, I think, the lead time in that case.
Yeah. So then, why cycle time is important is why is it important? It it gives it helps identify bottlenecks and improves the actual working process. How to calculate cycle time? Let me put for lead time also. Lead time is also a process metric. Total time from when a customer first requests something to is when he receives the final result. Lead time helps identify bottlenecks and improve actual performance. Helps in providing accurate service level agreements, customer experience, and complete delivery timeline. Helps in providing, helps in managing SLAs, customer experience, and complete delivery timelines. Okay, so
Okay. Yeah,
no, you're
sorry.
back. Okay, no worries.
Yeah.
Okay, so meantime, I try to fill for the lead time also some definition.
Uh-huh.
So for cycle time, why it is useful is it helps identify the bottlenecks. Like you mentioned as dependencies, wait times, all those, no, they come out,
Mm, yeah.
and we can improve. So once we remove all those bottlenecks, we will improve the working the processes
Yeah.
when we work on cycle time.
I think this also will measure the understanding or the mm, how well the story has been estimated,
Yeah, yeah,
forecasted. Yeah.
correct.
Yeah. And that
Mm,
way, I think it's useful for that in the
yeah,
sense.
yeah. Because unless you define or write the stories clearly with all the dependencies, with all the frameworks, everything in place, there
Yeah.
will be these kind of delays.
Right.
Mm. How to calculate?
Uh, cycle time, right?
Yeah,
Cycle.
calculate.
I think it's very straightforward in that case. I think the completion date minus
Yeah,
the start date.
yeah. I'll put that. Identify the
Uh,
start and end points
but
of an
what do you think? Is it good to put in a date wise, or you want to put? What if you consider it's an hour basis?
hour basis would be much ideal.
Yeah, I think that would be more relevant. I think.
Identify the start and end time, we'll
Yeah.
say, of a work item's journey.
Um.
The identify the start time of a work item journey and the subtract from the end time. No, no, from end time we have to remove the start time, right?
Yeah, and
Yeah.
time to start time. Okay, but then I mean, how practical is this? Because end date minus start date.
Subtract end time from the start time.
Uh,
How practically means?
um. No, how practically we can use it? Actually, my question is like,
Okay, so how means uh, when you're starting a project, first sprint is done.
hmm,
Our cycle time is 3 days. Over a
okay,
period of time, I will try to improve on that metric. And in case if I can come by 1.5 or 2 days, I can say 50% our process is improved.
hmm, yeah, they're also there. But uh, if we put it as a date wise, completion date minus the start date,
Mhm.
and that way,
Yeah, we'll
uh,
get days like 5 days or 6 days. How much a
yeah,
story is taken from start to
yeah.
finish?
Maybe say, for example, if a story is of three story point, and then that story point to complete, it may take maybe 5 working days or 4 working days, depending on the capacity and capability of that developer who's working with that. Um,
Okay, you're okay. You're thinking from that perspective, right? Because one
mm,
story pointer would be done faster, and the eight story point would be taking more time, something like that.
yeah. So that way we can relate to each other, right?
Hmm.
Because capability and capacity of the person, in the sense that some people will have been working in the project for a long time. They have more knowledge, so they can do things faster. And some a new joiner or a fresher who has joined recently to the team, he may not have the capability to uh, get the things at the same pace as the experienced person.
Those things will come into play. So
Yeah.
would they take an average of all? Average will not work, right?
No, that wouldn't be justified.
Average will not work.
Yeah, justified, because the person who's new will be under pressure
Ah,
if they
I
define the.
got it. So now
Mm,
what we are the cycle time is for a typical process.
mm,
And this process should be for standardized type of work items.
yeah.
So, and this is a Kanban board. So
Mm,
the tickets would be, for example, a typical kind of defects which are coming. So for all those, we can have one cycle time. So when we are calculating the cycle time, there should be standardization among the work items. Only for those, it
exactly.
will be apt to calculate cycle time. And in a
Exactly.
Kanban board, suppose take example of an IT team. So all
Mm,
the kind of requests what IT team gets are kind of almost same.
mm,
So for that team, over a period of 1 month, how much they're able to do this kind of work? That is the cycle time.
yeah.
My,
And I think this cannot be used at the individual level. It have to be the
correct.
team level.
Team level, yes.
Yeah, it should be in team level.
Team level and some homogeneity should be there because we
Yeah.
cannot put different kind of things and calculate cycle
Mm,
time.
yeah.
Some repeated kind of operational work.
Yeah. It could be something of finding the average of the works.
Yes, yes.
Yeah. Yeah.
We have the kind of homogeneous within that also some average of it.
Yeah.
Good discussion. So here I'll put note the work items to be homogeneous.
Yeah. I mean, similar kind of thing. Right?
Yeah, similar kind of
Mm,
thing. Yeah,
mm,
homogeneous. Example, operations.
mm,
So the same kind of things keeping on coming.
mm.
So there we can use all the cycle time, lead time, and everything. Okay.
Right.
Frequency. Frequency.
Uh,
It depends, right?
yeah. Cycle
Uh,
time. I think it will vary from sprint to
mm,
sprint, I suppose. It's not that
mm,
we can take a holistic path.
correct.
Yeah.
Depends on various factors. Each sprint or monthly
Mm.
or any
I mean,
agreed.
quarterly also.
Yeah, or any agreed frequency
Yeah. Or any other. Yeah.
where you want to measure
Mm.
process to measure the effectiveness of the process.
Of the
Okay.
process. Okay. ENC. Frequency.
Okay.
Mm.
Desired trend, there is nothing there, not applicable.
Yeah.
Okay. Now the last one, lead time.
Okay. Total time from
Uh, so this is cycle time is a subset
mm.
of lead time. Lead time would be the entire time from when this request is identified or when a customer asks
Okay.
till the time it is delivered. Cycle time is only when the start from work in progress to delivered. This is from the lead identification
Okay. Okay. Understood. Yeah.
till
From the
the
moment,
final
from the
result.
moment it has been identified that they
Yeah,
wanted this feature
yes,
to delivery, right?
to delivery.
Mm.
And this, what I have seen is it helps in for the SLAs. Because the
Okay.
customer doesn't bother whether you take it as sprint or working or not. For him, it is a problem.
Mm-hmm.
So for SLAs and all, we need lead time, and it
Right.
will impact customer experience,
Exactly.
delivery timeline. So
How
and
soon we can deliver
yeah,
the uh,
more of customer centric.
yeah.
How
I
to
think
calculate? Yeah,
it's
yeah.
this. I think it's a similar way. I think a requested date, completion date minus requested date.
Requested or identified?
Oh
I
yeah, identified or requested, or when we commit the
yeah.
requirement, the committed date, right? We okay. It yeah. There can be another interesting thing here is like how we do is like we the customers comes and make a proposal
Mm,
that they wanted to get this thing implemented, but then there's always a negotiation happens here
correct.
that we will analyze that whether this can be done within the time frame of, because we have
Mm,
quarterly release, and we analyze that it can it be done within a quarter, within the
mm,
next release. If it is done, if it is agreed, then we commit that requirement, say that okay, now we will implement this. Otherwise, when we feel that the number of people available for the team, number of time, because there are times difference, because fourth quarter normally is a holiday season that
mm,
comes in the picture. It's a holiday season. There are a lot of Diwali leaves in India. You have Diwali leaves, this, that, and in different regions have different holidays. Durga Puja is there, the Dasera is there. So many things are there. The factors that impacts the capacity of the team. That actually is one factor where when we estimate the deliverables for the next release, this comes in the picture.
correct.
So
Yeah,
we commit only those which we feel that this will be taken up for the next release.
correct. We need to
So
factor in all those things and
yes,
then give
and
a
yeah, although it is a very minor thing, but what I observe is that in every quarter or 2 quarter once, company provides mandatory trainings to the employees.
mm,
There's some of the trainings are mandatory, and they have a time defined time frame that we have to complete within this time. So
mm,
the employees are or the developers are under pressure to do the sprint work as well as complete these trainings. And these trainings are sometimes just the SOP that you can read it through. There are sometimes which is interactive, which takes more time.
mm,
So they have to adjust these trainings along with the sprint deliverables. So here, what we
correct.
have seen the challenge is that people tend to miss the sprint deliverables because they have these trainings piled up with the trainings. Yeah. So we
Mm,
have seen that, and we are expecting that during the year end on the fourth quarter, trainings will be again pushed into at least for us that is a process. So
mm.
we are expecting that in the fourth quarter, trainings will be pushed on, so we have to be ready to uh,
Yeah,
adjust the we have to keep a buffer for those
correct,
trainings also.
correct, correct.
Yeah, that actually impacts the lead time. What I'm trying to bring in here is this will impact the lead time.
Mm. So
Yeah.
here I'll say, hmm, for planning delivery dates, um,
Mm.
need to factor in various
Yeah, it's a lot of factors. Yeah,
non-development
like non-development hours or non-development.
organizational
Mm,
or ad hoc activities
right.
which teams need to address.
Yeah. In here, sometimes you have production issues also.
Yeah,
These are some of the things that is out of the blues. We never know that. Yeah.
yeah, yeah. So here I'll just copy this thing.
Yeah.
Identify the request creation time.
Yeah. Request request date.
Re-
Identify the request creation date and to the end of the delivery or the completion date.
Request creation date
Uh,
and delivery date.
yeah, and to the delivery date.
Hmm?
Yeah.
And then subtract the delivery date. So subtract the
uh, subtract the delivery
Ah,
date from the completion date.
delivery date from creation
No,
date, right?
sorry. Uh, request subtract the request date from
Okay.
completion
Okay.
date.
Subtract request creation date
Ah,
from delivery date.
exactly. Yeah.
Okay, then here also it may change, right? Subtract end time from the start time we said for cycle time.
Subtract it. No. Yeah, you have to change here also, I think.
Correct, no? This is start
Yeah.
time.
Yeah. So you start
Start
time.
time from the end time.
Yeah. Because end time is the larger one.
Correct.
I mean, it's a after the
Hmm. Okay, frequency, lead time. Again, this also depends on various factors.
yeah. It's all depend on
Yeah,
the. I think mostly this is on the entire.
the entire org, entire account,
Yeah.
how you're handling
So,
these lead times.
yeah.
Good discussion.
Yeah.
And I think,
Because these are small things, no? It actually matters when we come to planning the sprint or the deliverables.
hmm. And if you see in this call, we could complete only one part.
Yeah. It's a lot of things to discuss, I think. It's really good. I really enjoyed the discussion
A lot
because
of new
there are so
things,
many
right?
things that we learned,
Correct.
um, just by doing it. It's not that we have to open a book and then go through it, but it's more of practical. And when we do this thing, no, it comes to your mind so many things that because different organizations have different approaches.
Exactly. Yeah.
Yeah,
That thing we need that because theoretically we may know, but
yeah,
practically how to apply it in that context in
yeah,
those
yeah.
different that environment, right? That matters.
When I bring up the topic of the training, no, organization level training, it's because we had a big slippage in our sprint deliverables at the end of because we had a slippage. So when we do the RCA, we found that the team were bombarded with the this one
Hmm.
mandatory trainings.
Correct.
And actually, what happened now from the entire team capacity? Normally, I provide 15% of the percent as their this one buffer for that. That buffer is like, for example, a person is available for um, 10 working days for the entire sprint. He has 80 hours of 80 work hour. In that, 15% is around, I think, 72 hours.
Hmm.
72 hours is this one available actual time that we have to deliver. So what I make sure is that if the training is completed within that 15 hours is not only for training. You have daily
Lot of
stand-ups, you
other
have
things.
the sprint ceremonies are
Hmm.
all are there. So those things have to be done within this 15% buffer hour, and 80% 85% is the your mm, actual
Actual
output
core development. Yeah.
development work, and non-development work is the 15%. But sometimes when you have so many of trainings, no, they can't squeeze it that within that
Correct. Correct.
15%.
And
Yeah,
all these trainings will also be piled up, maybe towards the end of the year or end of the quarter.
yeah,
That time there will be a lot of training which they have to do.
yeah. That actually, and they are under a lot of stress because the organization make it mandatory that you have to
Correct. Correct.
finish within this time. Otherwise, so many mail, so many compliances mail will be shoot out. So even we are under pressure. We are tracking them, but we are also under pressure to make them to complete that mandatory.
Yeah. Yeah.
So I think this is one consideration that I think we should be asking, taking up while we are planning for the
Yeah.
capacity
Yeah.
for the sprint. Yeah.
Yeah. Okay. So we plan for three level of metrics. We covered one. Maybe next week sometime we'll spend on the other two. And again, we'll
Yeah,
block some time.
yeah.
Yeah.
Anytime evening also is.